Thanks everyone for joining. In person, we have around 20 people in the room. This is the first time we are doing this hybrid kind of thing, so that you already saw some technical challenges here, but thanks Alberto for taking time out and coming out and making it happen. Scott is not in the room. He actually pushed me to do this like in person, and glad we can do it. Quickly, so today, Alberto will be talking about the visual calculations, one of the biggest buzzword in Power BI. Well, I haven't used it yet. I played with it, but haven't used it. And glad this session is happening. So then I will decide whether we need to use it or not. Not going to take too much time here. Again, Vancouver Fabric and Power BI user group. I started with Sandeep around 4 or 5 months ago. If you guys don't know about Sandeep, he is more into data science world and notebook and all this stuff. Do follow him. He has a website called fabric.guru, easy to remember. He does everything related to Fabric. For me, I'm more into Power BI, guys. No as good as Alberto and Marco, but try my best. I do have my own YouTube channel. Please feel free to join that and connect with me on LinkedIn, Twitter, whatever works for you guys. And never hesitate to reach out. I spend a lot of time on community forum under PeryTUS as my name. So if you ever came across that name, that's me. Alberto, we know who he is. I will let him introduce himself. I'm just going to skip this slide for now. We're going to record this event. Hopefully this recording is happening, and the link we will share after the meetup today. Anybody who's remote, please keep yourself muted during the presentation. Raise your hand if you guys have any question. So my webcam is not working, so you guys probably can't see me right now. Prefix your questions with letter Q in the chat. This is more for the remote people, so that we know there's a question. I will try to Alberto, how you like the questions at the end or stop in, doesn't matter? Yeah,
whenever they happen, that's not a problem.
Okay, no problem. All right. And one of the things which we do is we do ask for a brief survey, which we have like takes less than a minute or so to fill it up. And then we do a raffle draw, which Sandeep has done using Fabric, some notebook and thing, and we do the draw. If you fill the survey, and your name will get in the draw, and we will do it right now here in front of everyone. So that's pretty much it, and I'm going to hand over to Alberto, and I'm going to mute myself so that there's no issue. And
if I mute myself, do you hear me?
Yeah. Anybody remote? Can you guys hear Alberto, please?
No, I'm joking. Don't make me sing. That would be really horrible.
Yeah, he's good.
Yes.
Cool.
You're good.
Okay, and I guess you will see me here, but I will stand up from time to time, so I will disappear for a while. Anyway, welcome everybody. We're gonna spend, I don't know, around 1 hour, maybe a bit more, depending on how this stuff gets boring, talking about visual calculation. The goal is to understand what they are and whether they are useful or not, and what are the useful features and the limitation. Just a couple of words about me, but really, really short. I'm Alberto Ferrari. I work with Marco at SQL BI. We do a lot of stuff related to tabular, and in the last, I would say 10 years, we basically work only on DAX. So my superpower is definitely working with DAX. And that's it. I'm not here to sell myself. So let's talk about the topics we are gonna learn. Visual calculation are a new feature, still in preview. The perspective, my perspective, the perspective I want to use during the session is that of a BI professional and a consultant. I would expect you to have some good DAX skills, because we will see a lot of DAX code. By the way, how many of you feel confident with DAX? Cool. I have no idea about the online person, but let's take the same percentage. The idea is to understand, first of all, how they work. So how to create a visual calculation, and then implementation, so how they are implemented, because that drives the limitation of visual calculation. There are things that they can do, there are things that they will never be able to do, there are things that might improve over time. And once we understand how they are implemented, that will help us understanding the feature and where it might go at some point. Its strength, its weaknesses, and most important thing, in my opinion, when to use them and when to skip them entirely, because you might then start a project saying, well, I might do visual calculation here and there, but if you know that's gonna fail, you just move away and do something completely different. And the expectation, not just because it was the expectation, because Microsoft presents visual calculation with a lot of hype, is that with visual calculation, DAX suddenly becomes easy. You don't have to learn DAX anymore, and that is available for everybody. You can write any calculation with no DAX knowledge. Today, basically, you need to use Copilot and visual calculation, and the life is easy. That's not going to work, but that's what they say. There's no need to learn evaluation context anymore. You need to do any kind of training. Santa Claus travels on Christmas Eve, and the tooth fairy is exchanging money for the baby teeth. Now, depending on your age and your experience, you might believe in one, some, or none of these statements. At my age and in my experience, I know all these are just lies. None of these statements is right. DAX is not going to be easier, and there are a lot of limitations in the implementation. But we need to understand them a bit better. Visual calculation can make some calculation. A limited number of calculation that would be extremely hard with DAX can be actually simplified by a lot using visual calculation. But you need to do cherry picking. You need to know exactly whether the calculation you want is part of the ones that are easy or not. If the answer is yes, you can go for a visual calculation and everybody's happy. If the answer is no, just move away and go back to regular calculation. Because the technical details are rather complex. The level of knowledge you need to have about the visual context, which is the new evaluation context created for visual calculation, is really high. And the level of complexity of basic calculation is the same in DAX or in a visual calculation. So what's the point of learning a new way of developing things is something that we need to understand. With that said, I don't like to use slides for nearly anything, so I prefer to do demos all the time. Let's say that I have this model, and I already have a visual calc here, so I get rid of it. Here I have a simple matrix that contains the brand, the sales amount, and the total cost. Brand and total cost. Can anybody tell me if the Zoom works on the remote? Because of that I have no idea.
Does a Zoom work on the?
Can you see really very, very large?
Alberto, are you sharing your screen through Teams?
Oh, no.
Can
that was a question, an interesting question to ask earlier.
Sorry,
but we are learning right now and getting back. So, this one, share content and the screen. Get rid of that. So now at least you see the screen with no zoom.
Yeah.
And what if I zoom in?
Can you guys see the zoom in screen? Yes.
Cool.
Yes.
So sales amount and total cost are two measures coming from the data model. Sales amount computes, as you might guess, the sales amount, and total cost just compute quantity times the unit cost. Let's say that I'm a user, I have no knowledge of DAX, and I want to compute the margin by subtracting the total cost from the sales amount. With a visual calculation, you can do that. You just go here, choose a new visual calculation, and this UI pops up. The table you see here is quite relevant because this is a table that I call the virtual table. It's the table that is the result of the query executed to feed the matrix. The matrix contains raw data, age, item, sales amount, total cost, and all these numbers. And all these values are fed into the virtual table. The virtual table contains not only the rows with the brand, it also contains the total. That is part of the virtual table too. So the entire set of data that is created is part of the virtual table. And you can create a new calculation here and just write a margin equals sales, not brand, but sales amount minus total cost. And that's it. You have your calculation, it works, and it's fine. There are a few details which are worth understanding. The first one is that you reference columns with no table name. If you are used to write DAX, you know that this is the way we reference a measure. We never use columns without the table name in front of it. The thing is, the virtual table has no name, so there are no ways you can provide a name, and that's the only way you can reference a column. And the second important thing, so we start to discover the details, you cannot reference measures from inside a visual calculation. A visual calculation is a piece of DAX code that runs on top of the virtual table, and the virtual table is the only thing that the visual calculation can see. If you want to call a measure, you can't. There are no ways you can reference it. The names you see here are the names of the columns. So if we go back to the report, for example, and we rename sales amount, saying I don't want to name it sales amount, I'll rename it sales. Now, the column in this visual is named sales, and if we go back in margin, you see that margin now uses sales. And if you try to use sales amount, that is the measure, it's not even there. If you try to call the measure sales amount, you just get an error because you cannot reference the measure. This is the first and probably the most important limitation of visual calculations. A visual calculation executes any DAX expression, whatever you want, but it is limited to what you see on the screen in your matrix. Anything else is not available. For simple measure, that is not a big deal. You can write a simple measure based on what you have on the screen, but as soon as you try to write something more complex and you want to make a condition like check the number of rows in a table, find the maximum data available, compute the maximum sales amount, that's not an option. You cannot have it unless you add it to your virtual table. So let's pretend that I want to compute not the sales amount, but I want to compute the average sales per customer. If I were to do that in DAX, I would just create a new measure, a regular DAX measure, and I compute average sales. I just call sales amount and I divide it by count rows of customer, or distinct count of sales customer key. That's the same. Distinct count of sales customer key. As simple as it is, this measure is using sales amount. It's calling a measure and is scanning a table, computing a distinct count. You drop it there, and this is the average sales per customer computed on the fly. If I were to do the same in a visual calculation, I can't, because I have sales, I have a total cost, I have margin, I don't have the number of customers. So what you need to do is create a new measure. Let's call it a number of customers that computes the distinct count of sales customer key. I add it to the visual. Now it's part of the virtual table, and now I can use it in my calculation. So I can create a new visual calc, and I compute average sales by dividing sales by the number of customers. And now I have my number that is computed correctly. I don't want to see the number of customers. You always have the option to hide visual, to hide the columns, exactly because you might need to have new columns in the virtual table only for the purpose of computing values here. So again, for simple calculation, that is fine. If your measure, the calculation you need to provide is not complex, that is absolutely fine and it works nicely. For complex calculation where you would need to scan different tables and do other operations, that is just not an option. If you want to go below the granularity of the brand, you want to discover how many products are of that brand, how many customers bought it, and do some complex reasoning, that's not an option. You cannot do that at all. And that's a very strong limitation that limits a lot of the feature. Then, to be honest, there are features which are absolutely simple to implement. If you want to create a visual calculation that computes, for example, the running sum of the brand, you just create a running sum and you say, I want the running sum of the sales amount. And that's all what you need to do. You see that the running sum works, and you have a running sum of the brand. So it works. It is nicely implemented for the few functionalities which they decided to make available through syntax sugar, because a running sum is nothing but a syntax sugar over a window function that computes the running sum with, again, some limitation. Look at the running sum right now. It's sorted by brand. What happens if I sort the visual by sales? Well, the running sum doesn't look so sexy anymore. Why that? Because it is still sorting by brand. Look at the value for a datum is 147. If I sort it by brand, the value is still 147. The sort order is defined not by the visual, it's defined by the visual calculation, because during the calculation, and we are going to see that in a minute, during the creation of a visual calculation, the sorting happens after the visual calculation has been created. So the visual calc uses the sort order that is defined in the metadata of the matrix, which is just the brand. Is this a strong limitation? We don't know. Can they change it? Maybe, but it's not that easy. And to be honest, that is kind of a serious issue, because I don't know how many of your users would ever want a running sum by brand. That's totally useless. I would like to have a running sum by sales, for sure. I might want to have a running sales by data, but the least thing that I want is a running sum by brand. That just makes no sense. And that was the first trial that I did that surprised me. Like, how come that they didn't think about that? That was like one of the main features that you would expect. However, it is what it is. Building visual calculations is simple. You can build very easily simple calculations, but it's not that easy. Visual calculations are just DAX expression. They are not using a different language. The main limitation is that they work only on the virtual table. You cannot access the data model at all. Nothing at all is available. The syntax is standard. Column references are used without the table name, and there is no table name for the virtual table. That doesn't create confusion, because you cannot reference a measure, you cannot reference other columns. So whatever you write, it just stays there in the visual calc. One thing that I forgot to mention is that visual calculations are not part of the model. You cannot see them anywhere. A visual calc is created inside the visual, and that's it. It stays with the visual. You delete the visual calculation dies. You want to copy and paste the visual from one, copy and paste the visual calc between two different visuals, you copy the code and move it somewhere else. They might be thinking about creating a repository, creating a different way of editing visual calc, whatever. But the important thing is that visual calc are tied to the visual, not to the model. Okay? And the last important detail is that visual calc are not part of DAX. DAX does not even know about the existence of a visual calc. Now we're going to see how they are implemented, and visual calculation are implemented as temporary calculated column on top of a variable that is fed by summarized columns, which looks like I'm speaking Spanish, but we're going to look at that into more detail. We have this query that's computing sales, total cost, margin, average sales, and running sum. Let's see the code that is being executed to prepare this visual. So we just go on optimize, performance analyzer, start recording, we refresh everything, and we have this query. Let me copy it, and then using DAX Studio, we take a look at that. Okay. Can you read at that size from the bottom? Say yes or no. Cool. We go through the column later. Let's start from here. DS0 core, this is our usual summarized columns. Whenever you run wherever you fill a method, you always have a summarized column that also computes the subtotal, and that retrieves a table containing sales amount, total cost, and the number of customers. That's the query building the raw data. But then in a visual calc, you can change the names. For example, sales amount is the name that we provide to the sales amount measure, but we know that in the visual, we renamed it to sales. So we need another step. The select columns renames this table, which is nothing but a select column from DS0 core. These are the original column names, and these are the new column names. Sales amount is now called sales in the variable DS0 visual calc input. So we have a variable that contains the result of summarized columns with the names changed. So it's getting closer to the shape of the virtual table. And then we have where the magic happens, this definition of the table. It's probably worth making it a bit larger. The table DS0 visual calc, it's a definition, that is a temporary table created for the lifetime of the query. So it's a table created only for this query. It's not a part of the model. The content is the variable, this variable, with the new names. And we have these rows with visual shape. What does visual shape do? Visual shape adds metadata about the structure, the hierarchical structure that I want to impose on the table, that consists of grouping by column and grouping by brand. There will be a column, is grand total row total, that is this column that tells me whether the row of the table is a total or not. Remember, the virtual table does not only contain this set of rows, it also contains the total as one of the many rows. It's a flat table that contains at the same level rows and all the subtotals. I have only one here, but I could have a much more complex hierarchy of subtotal that creates a very complex structure. So axis tells the engine that we have a table with a visual shape. There is an axis that we name rows, where the grouping by column is the brand, and there is a column total is grand row total that tell me whether this is a row total or not. Order by specified the order by, and it's defined here. We order by brand ascending. The densification process that is very, very technical. We describe that into article. It's a process to add the rows that might need to exist to compute some totals, and it's not worth spending a lot of time there. Once we finish this part, we end with a table that has axis, meaning that I can start navigating through this table. I can go to the total, or I can go to the individual rows. Because when I will scan the table, when from inside my code, I scan the table, what I find depends on where I am. When I'm here, I will find only one row. When I'm here, I will find all these rows. Each row, the structure that is imposed to the table is actually a hierarchical structure. By the way, anybody here familiar with MDX? Over the slides, you will see MDX coming back. So the same multidimensional model that we were used to use with MDX, somebody hated it, somebody loved it, is coming back because that's nothing but a multidimensional space with two axes that we need to navigate through. Then the remaining part is quite simple. There is this step that removes rows that are useful. And finally, here we remove columns that are not needed. The select columns gets rid of columns that are hidden. A column might be hidden. It is added to the variable, then added to the table, used for the calculation, and then it is removed. Now, where are my visual calculations? I created a lot of visual calculation, and they are nowhere here. They are at the top. Visual calculations are defined as columns. You can define columns in a temporary table created inside a query. That is part of DAX. It has been there for a long time, even though few people use it. It was mainly used for composite models. But you can create temporary tables in a query, and you can create columns, calculated columns on that temporary table. Visual Calc use exactly the same technique. They define a column margin, whose code is sales minus total cost. Another column, average sales, that divides sales by number of customers. Running sum uses a running sum over sales, and that's it. These are the definition of the column, which are created as temporary column on the table fed from a variable. Make sense? So when I tell you that visual calc are not part of DAX, there is no definition here to talk about visual calculation. What they did was added to DAX mainly this part, the visual shape that is added to the table. Everything else that is just regular DAX with no exception. The thing is, with the definition of a visual shape, they had to introduce also other concepts like the visual context, rows, columns, and other ideas to let users navigate through rows and columns. Okay? What does this stuff tell us about limitations? Well, for example, the order by is placed here. Can I order by whatever I want? I don't know. Can I use order by sales here? Actually, I can. If I edit manually the query, I could write order by sales. And the query would run nicely. I get my result. And if I do that and I order by sales, the value of the running sum, you see, it's no longer 124, the value that was there in the matrix, that actually we can still see. It was 147. If we sort it by sales, now the value is 346, meaning that the running sum is now running under a different order. So the question is, can they fix that? I don't really know. They need to change the way the communication happens between the visual and the creation of the query. It is a possibility. They need to change it. We don't know if this is going to happen. Can they sort by anything? I don't know. We need to understand it. For now, that is a limitation, but this gives us some hope. They probably have the option of changing it. Other features are not. So what I write here cannot access in any way the model. And that is valid wherever. So if I write here sum of sales quantity and I manually change the query to let this code access the model, will it work or not? We don't know. We can give it a try, we run it, and the answer is no, cannot find the table sales. So the limitation on the sort order seems something that can be removed. The limitation over accessing any part of the model, that is a stronger limitation. It's built inside DAX. You cannot define a column in a virtual table that accesses the model. It is what it is. Whatever is the reason, that's something that we need to live with. But that's already a strong limitation. And if you are thinking about how can I use visual calc, that's a really strong limitation. You cannot do a lot more. With that said, let's go back to the slides, because if I don't go back to the slides from time to time, this session will last for like 10 hours. Visual calc contains a lot of syntax sugar. The running sum we have seen a few seconds ago, you have seen running sum, column, bam, job done. That looks like beautiful. Indeed, with a visual calc contains a lot of this syntax sugar. You can run a running sum in an easy way. Let me just close the performance analyzer. Okay. So a running sum is very easy. Here I'm doing a running sum this time by year, and that is a bit more interesting. Running sum that slices by year and just computes a number. And there are other functions that you can use. For example, you can use first, last. Let's edit the calculation. So we open the editor. Let's say that I want the first value of May 2007. That will be the first value. I can just use, oh, there's no first. I can just write it. First value. I can just write first of sales amount. And that returns the first value, first ever. You see that it's the first no matter what. You can compare the current value against the first value. You can use last. You can use several functions, which are nothing but syntax sugar on top of window functions. So window functions were actually a prerequisite in order to build visual calculation. Then you can use window functions without visual calculation, but window functions are designed to work well with visual calculation. And this leads to the creation of this set of, I say, cherry pick calculation. You want a moving average, that's just a function. You want a percentage of a parent, the percentage of the grand total. The current value says to the previous one. That's very simple. You just write sales amount minus the previous sales amount. And that retrieves the difference between the current value and the previous one. Between 431 and between 263 and 168, the difference is 95. Okay? And it's a very simple calculation to obtain. The good part is that this works no matter what. You can see that I can change the hierarchy, expanded it further, and it still works. Here we have a hierarchy that is already more complex. We have one subtotal, another subtotal, a third subtotal. So you might expect this creates an axis with 3 different levels, the year, the quarter, and then the month. So the year, the month, and then the individual data with all the calculations that are done here. So with the usage of window function is greatly simplified. You can use many of the new visual calculations, and you can use rows and columns. What is rows and columns? Well, rows and columns give you access to all the rows and all the columns. Let's get rid of some of these calculations so we make it easier. Also that one. Let's make a measure, sales 2, which is sales amount. That just copies sales amount. Easy. The quick question for you, if I create a new visual calculation, sales 3, that is a sum of sales amount, what would you expect as a result? Don't be shy, you are expected not to know the answer. So whatever you say it's going to be recorded, but not going to be a big problem. The camera is not on you. You would expect the grand total, exactly, because that's the way DAX works. If you reference a column, you get the column value, but if you use a sum, you get the grand total. And as you might not expect, you get instead the value. Why that? Because sales 3 is actually translated into sum X over rows of sales amount. What is rows? Rows are the rows of the current visual. And I made it wrong. Rows contains everything. But actually, oh, no. It's sum X over values of rows of sales amount. So rows, which is a special keyword that is valid only inside a visual calculation, give you access to the rows or to the columns, because you have rows and columns. Right now we have used only one axis, but you can have 2 axes, so you have rows and you have columns. The semantic of rows is the opposite of the semantic of regular tables. Why did they do that? We have no idea. But if you want to access the current row, you need to use values of rows. If you write rows, that would be the same as writing all rows. So all rows is the same as rows. Indeed, if you do sum X over rows of sales amount, you get the grand total. It's the opposite of what happens with regular table. Regular tables, when you reference a table, it's filtered by the filter context, whereas rows and columns by default are not filtered by the filter context, and you need to use values to get the part that is filtered by the filter context, by the visual context. So you have rows and columns that give you access to this table and let you navigate through the different hierarchies. What happens if you create a calculation number of rows that does count rows of rows? What you would expect here, here, and here. Again, it's not being recorded, so whatever is fine. The same number everywhere or different numbers?
Somebody in the chat said 1.
1. You actually get different numbers. And this is interesting to understand because we have 4 rows at the year level. Rows does not return the rows, the bottom, the leaf level rows. Rows return the rows at the level at which the visual context is. And you can start thinking about the visual context as something that is a mixture of the row context, because you can access individual columns of the table, of the filter context, because you have the option of filtering the virtual table, with this additional property that tells you which level you are. Rows returns 4 at the year level. Rows returns 35 at the month level. And it's not returning only the rows in 2017. It's returning all the rows in 2017, 18, 19, and 20. That's why 35. It's a larger number than just 12. And if you go at the day level, you get 827. That's more than a year because it's all the years together. Meaning that in any cell, you can access any row regardless of which level it is. But at the same time, in any cell, you see the rows at the level where you are. Make some sense? Now, picture explaining this stuff to a user that wants to use visual calculation because they are simple and easy. That's not really the level of complexity that you would expect them to appreciate. You would expect something much simpler than that. However, it is what it is. Now, let's go back to slides. So you can use row and column, remove somewhat the complexity of window function, and there are predefined functions for some of the most common use cases. We learn about visual shape. This is a more complex visual shape that groups by year, month, year. It's grouping by year, it's grouping by month, and it's grouping by date. And we have the total in another column with the order by that specify multiple columns for the order by. Nothing fancy here. This is basically the visual shape of the visual that we have seen a few seconds ago that contains the full hierarchy for the date. With the visual shape, you define 1 or 2 axes. One is row, the other one is columns. One might be present or not. Both might not be present if there are no axes at all. And each axis is defined by the set of group by columns and an optional order by clause that is used by the window function to define how they behave. And visual shape is useful to add a hierarchical structure to the table that would be otherwise flat. But with visual shape, it becomes a much more complex structure. And the flat table, that is important, does not contain just the leaf level rows. It contains all the rows that needs to be organized in some way. And the way they are organized is with a lattice that we're going to see in a few seconds. Finally, visual calcs are computed as new column in the virtual table. Each visual calc is a new column. The original source is coming from the original summarized column, if you remember the S0 core. And then we shape it through visual shape. We remove the useless column. We perform the renaming. We add the new column, and then we have densification. But we're not going to talk about that. As I said, the virtual table contains a lot of rows, contains all the rows and all the subtotals. So how is it organized? Well, if you have a matrix like this one, here we have more subtotals than actual rows, because the rows are 16, 17, 23, 17, 38. These are 4 rows. And then we have 1, 2, 3, 4, 5 different subtotals only for this section. So there are a lot of rows for the subtotal and a small number of leaf level calculation. How is the lattice organized? Well, the lattice starts with the grand total. And at the grand total, the only column available is amount. There's no year, there's no month, there's no country, there's no city. The only column available is the amount. Then this is the top level of the lattice. Below you have one set of rows where you have the year and the amount. That is the subtotal at the year level. And you have the country and the amount. That is the subtotal at the country, because we do have the subtotal at the year level, 160 and 137. And we have the subtotal at the country level, 146 and 151. So these are rows in the virtual table, blanks everywhere, except for the column where it matters. And you can extend the concept. From this level, you can go expanding the state and you have this set of rows, or you expand the year and you have this set of rows. Then you expand the year again, or you expand the state, and these two levels collapse to the same. That is more detailed, but it's the same for both. So this creates a diamond shape that starts with the grand total. It ends with the leaf level calculation. This is the result of our summarized column. It contains the raw data with no subtotals anywhere. So this is where I would expect to do most calculation, but you can do calculation anywhere there. And the thing is, you need to know where you want to perform the calculation, because the visual context contains the raw context, the filter context, and the position you are performing the calculation inside the visual lattice. So you can picture the visual context as some sort of pointer that says you are doing a calculation and you are here. If you want, you have the option of moving the visual context to a different place, to the father or to one of the children. If you want to go from here to there, you need to get rid of the country. So you tell the engine, I'm at this level. I want to kill the country. I want to remove it from the column that I want to view. And if you remove the country, you go there. If you remove the year, you go there. From here, if you want to see the month, you go there, because the month is there. And from here, if you want to see the state, you go there. Make sense? So there are operations that move you from one point in the lattice to another point that depend on where you are and the operation you want to do. And these two operations are expand and collapse. So the raw context, the filter context, and now the visual context that doesn't follow the same rules as the other evaluation context. Is kind of different because it contains the position in the visual lattice. And then there is no raw, there is some sort of filter context. There is some sort of raw context, not really the raw context and the filter context, because the filter context filters the model, and here we cannot access the model. The raw context points to a row, and to respecting to that they are the same. There's nothing like a context transition because there's no effect in doing a potential context transition. And there is this position in the visual lattice. The visual context contains the level, we already talked about that, and the operation that you can perform are expand and collapse. From amount, you can expand the country and you go there, and the country is now available. From country, you expand the state and you go there, or if you expand the year and you go there. Make sense? Why is all this stuff useful? Well, let's pretend that on this model, let's get rid of some stuff. I want to compute the percentage over the parent. So I want to compute 168 divided by 2017. I can do that. You can use percent of parent, but we are starting to learn how it works. So let's do it by hand. Percentage over parent, it's divide sales amount, and that is the sales amount. And then I want the sales amount of my parent. How do I do that? If I want to go up, is it expand or collapse? Collapse. So I collapse sales amount. And it doesn't work. Collapse sales amount over the rows. Okay, It doesn't format them correctly. To format visual calculation, you still need to format them by hand, but this is going to go away as a quite easily. So that's one of the limitations that is going to disappear pretty soon. Now we have a percentage that is computed on top of the parent. Collapse tells the engine, I want to compute the sales amount, but I don't want to compute it in the current level. I want you to collapse on the parent level. Make sense? And of course, it shows 100% only at the grand total. Everywhere else, it shows a different percentage. Slow down. One thing that I forgot to mention is that my ears simply don't work really well. So if you want to talk with me, use a very loud value. Otherwise, I don't hear anything.
Is it just one level you collapse up with collapse?
Now you can collapse multiple levels. You can collapse and collapse and collapse if you want. You can collapse all. If you want the percentage of the grand total, you just do collapse all. And that shows you the percentage of the grand total. So now this tiny percentage is the percentage not of the May, but of the grand total, because I use collapse all. And it's worth to note, because that's a good thing about Visual Calc, that I don't need to name the columns that are present here. I could obtain the same calculation in DAX with a regular model, but I would need to specify the hierarchy. Remove the filter from the date, remove the filter from the year, remove the filter from the month, whereas this calculation works no matter what. If I remove the year month and I add the customer continent and then the city below that, you see that the percentage over the grand total still works nicely. It is not tied in any way to the hierarchy that I use. And that's a good thing, because I can move easily over the hierarchy without having to specify all these columns. How relevant that is, I don't really know, because a lot of calculation actually depend on what you, the place where you are and the calculation that you are performing. But it is nonetheless a nice feature. You can do calculations that are not necessarily tied to what you are seeing. Similar to what Excel has been doing for like the last 10 years, but at the end we have it. Yep. Louder, please. Otherwise, I don't really hear it. That's a problem.
Sort order limitations?
What do you mean by sort order limitation? Running sum, I don't know exactly the answer to tell you, but when I tested, that was a lot of time ago. This is now let's do another one, so we keep it. If you do a running sum, the running sum of sales amount, no, you actually cannot do anything. You can run sum the expression. You need to specify rows or columns. Then you need to tell the engine how to treat blanks. And for now, that is a useless. It's not used as a parameter. And you need to tell it when you want it to reset. But there's no way you can specify the sort order. However, if you want, you can build a running sum using a window function. So you can use a window function. And you do a calculate the sum of sales amount and use a window 0 absolute, 0 relative over rows ordered by sales amount. I hope it works. It might not be case. Indeed, it's not working at all. No, it works. And it shows now a running sum by sales amount. So I need to sort it by sales amount. Why on earth I decided to use the city that takes forever? So let's use the country. Now I have continent, country. I sort it by sales amount. And it's actually starting from 249. Here it works. Here it doesn't, because I guess it's taking all the rows. So if I get rid of the continent, that is running correctly. So you need to tell the engine to reset every continent in order to reset the running sum. But again, the thing is, that is not something for a user. That is something for a developer. You're a DAX developer, you learn window function, you know how they work, you can write this stuff. You are a user, you use running sum. So either they make running sum work easily, or there's no point. Instead of writing this, I would strongly prefer write my DAX code. That's the environment where I do all of my stuff, and I write code that can work everywhere in my model without having to revert to visual calculation. So while it is true that you can use the entire DAX, as soon as you move away from the syntax sugar, it's not that it's impossible to write, but the effort required is not worth. It's better to build something in the model. So we talked about the lattice, and I'm already out of time, so I'll keep on talking a bit faster. You can use collapse at the column level. So you can tell the engine, I want to collapse sales at the year, month, year. And this collapses the last level at which the year is available. And you can also use expand. If you expand the year, month, it expands to the first level where the year, month is actually visible. If expand or collapse are used in a level where the column is already visible, they don't do anything. Okay. So if you are already available to see the year month, because in the lattice the column is already there, they simply don't do anything. And you can also check with is at level whether you can see a column. You can check is at level country, is at level year, is at level amount, and the engine tells you in the current visual context, this column is visible or not. So you can query the column or not, because keep in mind that you cannot query brand or country or continent when you are at the grand total. There's no value there. So you cannot access the column country if you are at the level of the grand total. You should check if it's at level country, then give me the value of the country. Otherwise, skip it. And then you have rows and columns. Rows and columns retrieve all the rows and all the columns of a table. So they give you access to all the values. And you can use them to use window function, SUMX, iteration, count rows, any operation, just a table that just undergoes different semantics. And we have already seen that. Rows is equivalent to all rows, and values of rows is required if you want to obey the current filter context. You can also use rows and columns together for some calculations. It's easier to see that with this demo. This is just showing a rank function. I'm computing the rank based on rows, and then I'm formatting the result as a single number. If you just rank rows, it ranks rows column by column. You can decide to do rank on columns. And that ranks columns one by one. And you can also use I wish it was a bit easier. Okay. Rank on rows and then columns. And then it goes from 1 to 12, and then it starts again at 13, 24, 25, 36, 37. Or you can use column rows. One, two, three, four, 5, 6, 7, 8, and so on. So you tell the engine which axis to use in one way or another. You can also tell the engine to reset at the month level, to do these calculations in different way. And this concept of ordering of the table is applied to most of the calculations, like running sum, ranking, averaging. You specify the order where you want to reset and how you want to continue from one axis to the other one. That, I have to say, is user-friendly. So a user can learn it by looking at several examples. They get the feeling of how to make them work. So you can use columns, rows, columns with a reset. So you reach a point, then you reset and you start ranking again. Rows, then you reset, then you go again, then you reset and you start counting from one, and so on. And then you have set of functions like previous, next, first, and last. This is nothing but syntax sugar for offset and index, the usual window function that we use in DAX. Range, that is nothing but, again, syntax sugar for a window function. You can compute the average of sales amount using the last 29 rows, including the current one, and using the rows as an axis. That computes the average over 30 days. But you can also compute it using, again, syntax sugar, moving average, which is syntax sugar for range and average used together. These are all functions that are designed to make it easier for users to design code. If the function exists, it's actually simple. So any user can compute a moving average. Anything more complex than that is kind of complicated. Running sum, that computes a running total, and you can use running sum along with rows, columns, and reset to obtain a different kind of running sum. And calculate works exactly like in a regular calculation, with the difference that there's no context transition. You can only work with the visual context, and you have the option of changing the level. You can write calculate whatever you want, expand, collapse, expand all, collapse all. So you can use these as calculate modifiers to change the level at which calculation happens. You're at a level, you expand to a different level, and you perform your calculation. With that said, let me show you in the last few minutes some examples. Before we see the examples, a word of warning, just to have a feeling of what you're about to witness. I prepared these examples over some time while learning visual calculations, and I was preparing a white paper, so I wrote a lot of visual calculation. My goal was really to find a use case. So I wanted to say, this calculation with visual calculation really shine. And whenever I sent that white paper to market for a review, the paper was coming back with a comment saying, Alberto, I like the example, but can't you find something where visual calculations are really useful? And I was saying, I'm trying. I'm really desperately trying to find a calculation that is easier with the visual calc than with a regular calculation. And I wasn't able to find any, apart from some simple ones. As you are going to see, as soon as the calculation becomes a tiny bit more complex than running sum or moving average, the complexity skyrockets very, very quickly. And I'm not going to explain you all the details of the code, just highlight some of the points. Let's look at them. The first calculation that I did was the percentage against 2017. So the idea, I'm thinking, I'm a user. I have on the screen the sales amount of 2017, and I want a new column that computes the sales amount of 2018 and the percentage against the value of 2017. I could have used first, I wanted to focus on 2017, just because that is the number that I want, okay? This might be a different brand. I might want the percentage against a specific value. And computing it is not hard, but it's not even that simple. I love this editor. Indeed, I always need to go to Visual Studio and copy and paste the code here to read it. Percentage over 2017, I divide sales amount, and then I need to expand because I want to place a filter over the year. Now, in order to place a filter over the year, when the calculation happens at the grand total, I will not be able to filter the year. because at the grand total, the year is not there. It's not visible. Unless I expand the columns to reach at least the level in the lattice where the year is visible, I cannot search for 2017. Make sense? So at the grand total, this calculation would not fail, but return a blank because 2017 cannot be searched for. That's why I need to use expand at least at the year level. Once you are at the year level, compute the sales amount where the year is 2017. That works, but again, to be honest, explaining to any user this expand stuff, it's not so trivial. You need to tell the user, you can perform the calculation, but you need to make sure that you are in a point in the lattice where that column you're using for the filter is visible. So you need to expand at that level. Not really intuitive. And you see again, MDX starting to show up. Another calculation, the percentage of parent. That's simple, we already wrote it. So this is actually an example where visual calculations are nice. Divide sales amount by collapse sales amount over the rows. Then you will see this format part in all the measures. Forget about that. I mean, that's a temporary limitation, not something that we need to worry about. The real code is here. So percentage of a parent is actually a good example. Moving average, well, the moving average, I wanted to do that a bit more interesting than just a moving average. Otherwise, that would be a moving average and that's it. I want the moving average and I want an arrow that says go up, the trend is going up or the trend is going down. So I compare the previous value of the sales amount with the current value of the sales amount. And if it is going up, the arrow goes up. If it is going down, the arrow goes down. So I have the moving average and the trend in the same calculation. That looks like a nice example. I mean, a user would like to build this kind of visualization. And trust me, I have no idea of the code. I totally don't remember the code. So I'm curious as you to see the implementation. Let's see what I had to do. Not that bad, to be honest. This is just the Unichar code of up and down arrows. I get the current value, computing the moving average. What is this moving average? This is the moving average and trend. So I actually have a column moving average, which is hidden that computes the moving average. Let's go look at that. Otherwise, I'm cheating. Not that simple, because I want to do the order by, oh, that's really cool. I want to do the order by year, month, number. Okay? That looks simple, it is not. Again, that gives you an idea that they didn't bake the feature as they wanted. On the rows, I have May 2007, June 2017, July 2017. That's the month name. But I'm not sorted by month name. I'm sorted by month number. Of course, month name are not sorted by month number. But by default, the visual is sorted by month name. It's not sorted by month number. Month number is part of the column, but it's hidden and not used for the sort visual. That is really weird. I mean, you should not think a lot to think that that's a feature that is actually needed, but they didn't. So you cannot create a moving average by month number. The syntax sugar simply doesn't work. Therefore, I needed to create a window -1 absolute, -1 absolute of the values of the row ordered by year, month, number to compute the moving average the right way, if I'm not at the level of the year, month. Not really easy, not really simple, but it computes the moving average. But again, that's not something that a user would ever write. Too complicated for them. So I compute the moving average. I get the previous moving average over the rows ordered by year, month, date. And then if the current value is greater than the previous value, up arrow, otherwise down arrow. Not that bad. I mean, apart from the moving average that is kind of complicated, and maybe they fix it once we signal the problem, this is an example where the visual calculation might make some sense. Can you do that with regular DAX? Honestly, yes. If you think about that, this is not a complex calculation. The moving average might take some time, and might be an advantage of visual calc. Once the summarized column is being executed, everything else is just calculation over the virtual table that is rather small. So the moving average doesn't require you to compute the measure all the time. It only computes the values on top of the virtual table that has already been computed. Whether this is going to improve performances or not, we don't know, because the indication tells us that we should not evaluate performance for now, because performance are not final. So it would be a waste of time. The growth against the previous year, that's not that complicated. But if I place it here, I would expect, well, no, that's a simple calculation again. The sales of the previous year is the previous sales amount over the columns, the sales amount, and the result. If sales amount is different than 0, then perform the division of 1 between the other. That's pretty simple. The only limitation, the only strange thing is that you can take the previous over the column, so you cannot take the previous year. You need to take the previous column. So the year needs to be on the column. If you place the year on the rows, you need to change the code. But as a user, that's understandable. There's no concept of the current year and the previous year. That's rows, columns, and whatever is on the visual. So far, we haven't seen any complex calculation, but then I tried to do something interesting, something a bit more interesting. This is computing a YTD. 2017, 2018, 2019, and 2020. The complexity here is that the YTD requires to compute, to avoid showing value in the future. I don't want to repeat 769 for the remaining months because there are no sales, so I want to skip it. I don't want to fill the values here. I want to reset every year. So if you were to compute a YTD in the model, in DAX, you would write something like that. Search for the last year, compute the first date in the last year, check for the last date ever, and if the minimum date is less than the last date ever, then compute the YTD, otherwise blank it out. All this part of the code is not needed for the YTD, it's needed only for visual purposes to avoid showing the value if I'm in the future. What makes it so hard in write code like this in a visual calc? Well, that this entire part simply cannot be done. You can compute the running sum easily, that's fine, but you cannot check for the last year that is in the visual, so for the minimum date in the last year or the maximum date ever. These are all calculations that are not available because I need to access other parts of the model, and that is not a possibility. So either I add this calculation to the visual, or I go for something more fancy. And this code, I remember, is definitely not easy. I wrote several different versions. Sales YTD 1 just does a running sum of sales amount. But you see that it shows values for let's see if I can. Okay, sales YTD 1 continues showing the value, and the numbers shown here are just quite weird. They are not precise, and it continues in the future. Sales YTD 2 introduces some complex logic, and it checks if you're at the level, compute the running sum of sales amount. Otherwise, search for the last year, compute the last YTD, computing the last YTD, and return the last YTD. This is actually needed to fix the value at the total level, because otherwise the total level will be a running sum of the totals producing a stupid number, whereas at the total, I want the last of 2020, the same ways as YTD behaves. And this code is already a bit complicated to show the total. The last version of YTD is just a nightmare because that handles all the complexity of the YTD. If there are sales in the current month and the year is at that level, then compute the running sum of the sales amount. Otherwise, if you are not at the level where the year is visible, then compute the sales of the last year, expand compute that, and if there are sales, compute the running sum where the year is the last year, and then return last year, expanding everything at the level of the year where the calculation can happen. That's code that I write doing trial and errors and obtaining the result, but no user would ever write that. But not even a professional. I would refuse to write code like this because why? The real question is, why should I do that at all? If I can do that with a model measure, I do that there and I'm much more happier. There's no much happier, not much more happier. There's no need to revert to visual calculation. So let me skip all this part and we can go straight. Oh no, there is still a demo. And I have a couple of minutes. Sorry for you. Where is it? The average of the siblings. I want to compute, I check the sales amount against the average of all the siblings. So all the values at the same level. So 3033, the average is 3084, which I guess the average of all these values, 3437. Average should produce this number. And this shows that the sales amount in 2017 is average compared to its siblings. Whereas 168 is bad compared to 379, that is the average of all the values between May and December. Make sense? That is not hard to compute, but requires a couple of strange operations. Because I need to compute the average of the siblings, and to do that, I need to calculate the average of the sales amount, expanding the rows after I have collapsed the rows. Why that? Because you are on one row here. You need to collapse and go to the father, and then expand to go and show all the children. Once that happens, you see all the children in the rows, and at that point, you can compute your average the right way. Again, is that intuitive? Well, I don't know. If a user is willing to learn all this stuff, it makes sense. I don't find it so intuitive, even though I liked MDX at the time. And then the indicator, that's easy. The indicator just uses a switch. If the sales amount is less than the average of siblings times 1 minus delta, where delta is 15%. So if it is in the range of 15% of the average, then it's average. Otherwise, it is poor if it is less, and it is good if it is above. That part is simple for any user. The average over siblings are probably a bit complicated, but that's the kind of code that finding on Google user might be able to write. So let's draw some conclusion about visual calc. They are useful to author simple calculation. They are stored in the visual. They are perfect for measures that are tied to the specific visual. Right now, you cannot use them for conditional formatting, but you will be able to do that. You cannot use them to do some operations on the table, like changing the title, maybe stuff like that. They are probably going to go in that direction. So for a measure that is tied to a specific visual, they make sense. You have a formatting condition, you want to do something fancy, you can create a visual calc, it stays there, you don't pollute the model. But as soon as the requirement become a tiny bit more complicated, well, things are very different. At that point, you need to decide whether the complexity of writing DAX code in the model is more than writing the measure with a visual calculation. Knowing that with the visual calculation, you don't have very long legs. You don't have the option of going very far. Whereas with the model, well, you have years of experience with DAX and you can do nearly whatever you want. So I feel much more confident in writing DAX code in the model than writing a visual calculation. That's my opinion. Then you might create yourself. But not being able to access the model is a major limitation, and navigating the lattice, well, that's definitely not something simple. Requires some getting used to, and it's important to decide whether it is important or not to learn it. Some limitation will be removed, some others are tied to the technical implementation. They are still in preview. We have no idea how long they will stay in preview, but I don't expect all the limitations. So overall, is it going to change the world of DAX? Not really. They are a nice feature, definitely not a revolution. They are a nice addition. Somebody will use it. I would expect some sort of limited usage of the feature. And if I were a consultant, I would not drive a solution there. I would just stay with good old model measures, maybe trying 1 or 2 visual calculation, but don't spend too much time there, because as I said, as of now, they are not going to change the world entirely. Nice, but not the revolution they expect. And I honestly think it's a missed opportunity, because there were a lot of ways they could have done it way better. They didn't. What is missing is that if you write a visual calculation, you cannot move a visual calc to a model measure. The two are so different that you cannot let the user say, well, start building a visual calculation, then you give that to me, and I will transform that into a model measure. That path doesn't exist. So if they write a visual calc and you want to build a model measure, you need to start from scratch. Let's start with the model measure first. That would be better. They could have created a way for the model measure to communicate with the visual. Can you picture if you had a way to, in a measure, in the model, to query and say, what is the shape of the visual I am in? Do I have a hierarchy? Can I navigate to the parent node? Can I do stuff like that? If you could that from a model measure, that would work, and that would be beautiful, because you use a visual measure, a visual calculation, and there is a path that you can move towards a model measure. But again, that is not what they implemented. So to me, because a visual calc doesn't have access to the model, they could have created a much simpler language only for visual calculation, or just use menus like Excel does. Excel does this stuff since ages, and there's no language for that. It's just post-processing that works and users are happy. So I don't see why they spend so much time building the feature, because the final outcome is quite not depressing, but not really exciting. And with these beautiful words of encouragement about learning new stuff about Power BI, thank you for staying with me so long, and hope you enjoyed. If you have any question, I'm here, and just ask.
Awesome, thank you. Yeah, I mean, we playing with visual calculation again, the very basic stuff, but this deep never went that far. Glad we did not end up seeing.
It was interesting to see all the details.
Yeah, so great. Yeah, thank you. I'm just gonna ask, is my mic on now? Let's just double check. Anybody have any question online there? All right, I guess you guys can hear me, right? Yes, all right, I'm gonna share my screen quickly.
I do have
All
one.
right.
Oh,
perfect. Yes, online, anybody can confirm if you guys can hear me? Yep, perfect, awesome, thank you guys. All right, if you guys have any questions, just type in the chat. Just quickly, we have another session coming up on October 10th, which will be online, not in person. Gerard is going to walk us through Fabric Studio for VS Code. It is at 8 a.m. PST. So because he's in Europe, and we're doing at 8 a.m. Thank you very much. So stay in touch and thanks for coming. Thank you. And do come and join us for the future events as well. Thank you.
Thank you.